Alrighty, it is PowerPoint time. It is the first time in the entire length of the course so far, and we are at the halfway point that I've actually done this. So let's take a look at one of my nightmares, and that is project planning. If you're doing a small project, such as the one we are going to be doing, it's not necessarily 100% needed to do a project plan, but it's a good project to start with. I will say that this way I'm going to show you is simply one way of doing it. Other people will have their own. I'm sure somebody out there in the wide web world will jump on this and say that's not the way you do it. This is just the way I do. So planning a project, and one way of doing it. First of all, we need the specs of the program, and I give you this tip: don't be too ambitious. Keep your project simple at first, add features onto it later once you've got your code base stabilized. 1. You need a basic description of your project. What does our project do? Let's get clear in our mind what our program is supposed to do and what it's not supposed to do. Leave out those things which are very possibly going to be complex to do. Do we have a name for our project yet? This is optional at first. You can come up with a stunning name later, but come up with something now which is at least somewhat descriptive temporarily. What programming or coding languages are you going to use? In this case, of course, it's PHP, but it could be multiple languages: PHP, JavaScript, Perl, HTML, etc. Does our project use a configuration file? Does our project use custom error handlers? And I'll tell you what those are later. Does it use CSS? Does it use structured query language? And is the appearance of the program customizable by the end user? So what's our project? Our project is a web gallery with thumbnails and watermarks on the images, so that they make them useless to steal, basically. The name is the simple PHP web gallery. How original is that? The language is PHP, that's our primary language, with some, a very tiny some, JavaScript and a bunch of HTML in it, because of course it's meant to go out on a web browser. It does use a configuration file. It does use custom error handlers. It does use cascading style sheets. At least for now, it does not use structured query language. And the appearance is not customizable, at least in our first version. Okay, let's go on to libraries. These would be code that you reuse over and over and over again, but you constantly have to type them in. So you can put them into a file and keep them and access them by doing a require once and include, or a require depending on which you choose. And the longer you code, the more you'll find that you start to collect these routines that you type in or use over and over and over again. So rather than typing them or copy and pasting them into code, the easiest thing is just to create a library. And what I'm going to show you here is the simplest form of a library, which is simply one of those little snippets of code that you use over and over again. And in this case, we see we have a basic math library. No, I don't use this code as a rule. This is just an example. And inside here, I've got one routine which consists of 4 lines of code. It is my divide two numbers. It takes two numbers, divides them, and returns the result, or sends it back to the calling routine. It's always a good idea somewhere in your library to do a comment series like this which documents it. So value 1 is your first number, value 2 is your second number, and you divide value 1 by value 2, and the result, which is value 3, is returned. So if we go to this little test program that I've created here, you'll see our standard opening and closing delimiters, a require once tag, which includes this file, math.php, and you'll see that I've created two variables here called $number1, which equals 10, $number2, which equals 25.5. I've used this math demo before. And I've created a third variable called $answer, but in this case, $answer calls my divide two numbers, feeds number 1 and number 2 into it. The routine divides it and returns the answer. And then here we print the answer, which is contained in $answer. So let's see if this works. And yes, it does. 10.00 divided by 25.50 equals 0.392. Now you'll see that when I'm doing these decimal places with the floats that I've done it a little bit differently than I did before. The one I did before was basically just a one number float, so it just, when you do something like this, what it does is it would print the first number here instead of the actual answer. So this is really only when you're dealing with one number. Just leave it like this. %3, so we want 3 decimal places and it's a float. Now I want to go into error handlers. As you recall earlier on, I talked about this mysterious thing called an error handler. And basically, PHP has its own built-in error handlers, but you might want to have a custom error handler which takes your errors and spits the message out in a format that you want to see. So let's take a look here at this. Now I will spit out one caveat at you, and that is, if you're going to put error handlers in your scripts, you have to be careful what you reveal to the end user, the person browsing to your website. If it's just you and it's just on an internal computer, you don't have to worry about it too much. But you can leak information to somebody who wants to attack your website if your error codes actually spit out error messages with something in them that could be valuable to them. And a perfect example of that, I'm just going to open up the WAMP icon here and go to its demo page here. Yeah. So you'll see down here under Tools, you'll see PHP Info. And PHP Info, if it's enabled on the web server, will spit out all kinds of information about the web server and about how PHP is configured. Like there's a graphics library that's turned on, and there's an email library that's enabled. LDAP is enabled, Lightweight Directory Access Protocol, XML, and so on. A lot of web servers will turn this off and not give you the ability to see what's in there because it releases information about the computer. Here's a perfect example. The configuration file for PHP is stored in C:\Windows, and the configuration file is stored in this directory. This kind of information is not something you necessarily want leaking or available to a hacker. So let's take a look at our error handler function here. First of all, we've created a function called MyError Handler, and it has 4 values that you feed into it. By the way, this error handler is almost exactly what is available on the php.net manual. The very first function here basically says that anything not included down here, no, because there are multiple error messages available to you, handle it with the default standard PHP error handler. Now here's a new command that I haven't told you yet. It's switch. The switch is similar in many ways to the if command. What it does is you go switch, and then you have error no, which means error number. As you recall in class, each error type has a number that goes with it. You can also use a textual alphanumeric descriptor for it as well. So switch error no, and then here case is basically saying if error no equals this, then you execute this block of code. Exit means to stop the execution of the code. Break does something very similar, but except at this point is if the code executes, you return to the calling routine. And then we have a warning. This is for an error, this is for a warning, and this is for a notice. Then the default is, I don't know what error type it is, so I'm going to give you this message. Now remember, those two things are functions. They don't actually execute unless they are called. So down here we see set error handler, and we have our routine name up here, which is MyError Handler. And basically what this is saying is that the routine that will be handling errors is this one, the one we've just looked at up above. Now the rest of this code is really just devoted to demonstrating the error handler. So it's throwing deliberate errors, except for this first piece of code here, which is basically just printing out these values to demonstrate the numbers we're going to be using to generate the errors. So if I run this, here we are, here's the title, vector A, and it's just spitting out our 6 values, 2, 3, foo, 5.5, 43.3, and 21.11. And then we get the errors that the code is deliberately generating in order to demonstrate. So the second one is taking our number and multiplying a log of pi against our number, which will be coming in series through here. So basically this would be log pi times 2 log pi times 3 log pi times foo, which it wouldn't work unless we handled it, log pi times 5.5, and so on. And then down here we have a fatal error which causes the code to exit. So if we go back up here, what's happening? Well, this first one again just assigns these numbers to $A and then prints it. The second one echoes out a little line that says what we're doing. And then what we're doing here, $B equals the results of this mathematics up here, which is this one. And here's something that will be somewhat confusing. This was capital letter M underscore pi is basically just sending pi as a number to the calling routine. This is just kind of a shortcut for it. As you may or may not know, pi is actually equal to 3.1416 ... and it carries on and on and on and on. So what happens when we call this routine here, which is scale by log, and we're feeding 2 numbers to it? Basically, because of what we're looking for in here, oh wait a minute, we go down here because of what we're feeding it. So we create an empty array, and then we have a for each loop, which basically is taking the position. Vector has our whole array in it, so we're taking our vector and we're assigning the value and the position. So this will be 0 through 6, and this will have the value of this in here. And then we do a comparison. If the content of value is not numeric, trigger an error. And then our value, which was foo at one point in time, will be assigned to 0, and then we calculate our log and then go through the loop again, and then we go back to the calling routine. Now this is basically just a demo routine. You'd probably want it to do more than this, and when we do work out our final error routine, our error handler for our gallery, we will actually log our errors to a file and spit out a generic message at the user that basically tells them nothing. So that was it this time around. I have one more thing I want to show you. Those of you who were there on Thursday would have known that my little snippet of code gave an error, and I couldn't figure out at the time what it was. I hadn't coded a long PHP script for a long time with multiple functions in it, so it gave an error message, and one of the things that I had forgotten to do was this. It says global $web title, which is our title, which would appear in the tab of the web page on the browser. Basically what this does is, inside of a function, if you want to reference a value that's outside of the function, in this case it's in our config page, which is included here, we have $web title, which simply equals PHP gallery in this case, which is required up here. You can't reference it from inside here. I would have to put the title in here again, but you'll see the global keyword here and then $web title. What this tells the function to do is to look for this variable outside of our bit of code here. So let's take a look at what happens when I run this. Now I've got two pictures of mine in here which do actually have XIF data in them. So if I pick this one, which is the eclipse, there you'll see the date that the picture was taken was the 21st of January 2019. The camera's a Pentax, K10D, exposure 1/60th of a second, ISO 400, focal length. There you go. So yes, I did clean up the code a teeny bit, and this is available to you on the SourceForge page. And now the definition of XIF, I misquoted when I told you what it meant. It's not extended image format. It stands for Exchangeable Image File Format, officially XIF. It's a standard that specifies the formats for images, sound, and other tags used by digital cameras. In other words, it just specifies all of the data that's stored within a picture. And what we saw here, you go back again and click. This data that you're seeing here is just a subset that I've picked to display. There are lots and lots and lots more of these that are actually available. Now this one says that it's taken on the SLR, and this one is taken on my work cell phone. There you have it. That's all there is for today, and we'll get some more later.